Welcome to the AV Magazine stand and Thursday of ISE. I can't think where the week's gone, but here we are. It's been a great show so far. Lots of people plodding through. Thursday's a pretty busy day, and we're continuing with our yet another session on our Get to Know Technologies, and hopefully we can understand them type of session. And with us today, well, we make an effort anyway. We have the utterly fabulous Karl Lang, who's president of Lumita, and Greg Jeffries, whose name I almost forgot then, but I'm human, of course. From Paradigm, image quality, color light output, color measurement, and so on. All these particular approaches to color, with all the hot lasers that are being revealed at ISE this year, just making some sense of how we should measure their effectiveness according to application. What do we know about color? How do we measure? How do we make sure we got the right color? We know what to get, and therefore look at this information on displays and projectors to make sure we're looking at this technology in the right sort of way. Now, Karl's done an awful lot of work on color light output, and he's going to give us some explanation of where we are with it and how he can help you. But the question we've got to kick off with Karl here, we're bombarded with lumens, and the next projector's got 6.5, 7,200, whatever it is, all these lumen figures kicking about. Where's the realistic assessment of what these projectors can do, or where does this color light output come in?
Well, color light output is designed to replace the old metric, right? So we had a metric that was developed in basically the late 80s, early 90s, and the only technology at that time were 3-gun CRT projectors. Okay, so we had 3 CRTs, red, green, and blue, and big lenses in front of them. They didn't put out a lot of light, and the way you measured the light output was fairly straightforward. All we had to do was basically fire up all 3 guns to full. So what do? You send the input signal of white, because red plus green plus blue equals white, right? So the simple test, what everybody knows is ANSI lumens. That test was simply put a white screen up, measure 9 points on it, because uniformity is never good, right? So we measure 9 different points on the screen, we add them together, and then we divide by the screen area. That's what the lumens number is that you see on every specification sheet for any projector. And that worked great. And it worked great for a long time. It worked for those CRT projectors, and it also worked for 3-chip DLP, and it worked for 3 LCD, and it worked for 3 LCOS, okay? But when we started to get new projector technologies, when we started changing the light engine to laser phosphor engines, when we started getting 1-chip, 2-chip, and 4-chip projectors, those particular projectors use completely different technology to create light on the screen.
It gets so confusing.
It gets very confusing, but more importantly, what happened is that the light output spec broke. Okay, these new technologies were reported. If you use the old specification, that new specification didn't work. The old specification didn't work anymore. If it said 7,000 lumens, yeah, it produced 7,000 lumens of white, but your colors looked dead. And so people could buy 5 projectors that were all, say, 7,000 lumens, but they had completely different color brightness. So what happened in the industry is that we needed to fix that. And it's taken us about 8 years to create a new specification to replace the old one.
Can I just hold you there for God? Have you, in your experience of handling some pretty tricky applications, you had quite a specialised knowledge in all this sort of stuff. From your installation integrator type of point and application development, what problems did you have with this? Did you look upon this in the same sort of way? I'm just wondering what your community would say how realistic an expectation has it of the potential of projection? Are the guidelines and measurement data accurate enough to give you a good idea of what the projector is capable of doing, and is it clear enough?
Well, in practice, the disappointing thing is that no matter how many dollars or pounds or euros people spend on a projector, is that they don't even do the very basic things to get them installed correctly, and whatever their performance could be. 99 times out of 100, and I'm not exaggerating, they're never going to be installed correctly in the first place. So I think it's actually, the timing of this standard, and to have some kind of awareness of it, because the difference between the input going in and then what comes out of the projector, and then which is even more different, what happens when it reflects off a screen, and then additionally what happens when you get ambient light levels of a certain point. Those are the kind of the practical things that kind of that bug me. So I think that this is a very helpful exercise, because it's a way of framing people's awareness. Because I think people tend to think about this the wrong way around. they think about, I'm going to buy a projector and a screen, and it's very mechanistic. I think if people can think about, the content, and then from that what they want from the content, which of course is color. I think this is a fantastic way of approaching it.
We're sort of screaming out for something like this, aren't we? It's taken a long time to develop that. You've been working on this for a while, haven't you?
Yeah, actually, well, not just me personally. So this new specification, color light output, that's been designed to sort of solve this problem in the specification sheets, has been developed. It's right here in this big green book. But actually, this is from the International Committee for Display Metrology, a bunch of eggheads. There's a whole lot of us in there. And from about 50 different companies, all the top projector manufacturers, display manufacturers, everybody who's in the business of color has worked on this committee. We first started taking data on all of the different projectors in the market, like I said, about 8 years ago. We published 2 or 3 scientific papers since then, done deep analysis, and then we developed the new metric so that it would be completely fair to any projector technology. The goal was to take the original metric that used to be fair to everybody and come up with a new metric that wouldn't change what consumers and buyers and installers used, because they're so used to that number, lumens, right, that we don't want to change that. So what we wanted to do was change the method of measurement so that the number stayed the same, but it accurately reflects actually what the projectors do today. And so that's all this is that we've developed this new standard, and it was almost unanimously voted in by everybody on the committee. So it's been a long road, but now we have the standard, so now we're out trying to talk about it.
But how are the consumers and the buyers going to know about it? How are we going to be able to?
Hey, this is an example of it right here, and you can come to the stand. Right, I'm trying to do my bit. Everybody's trying to do a bit. All the people who have worked on this. Obviously, there's going to be a lot of different manufacturers that are going to do this. Okay, you already see the new metric on a bunch of manufacturers' products, and that's really important. Absolutely.
Do we know which manufacturer?
Sure, Epson shows it. You're going to find it on Sony products. You're going to find it on some Hitachi products, and hopefully pretty soon you'll find it on all products. But obviously, the most important thing, if you don't see it on a product, why? Okay, you should be questioning and saying, hey, what is the color light output of this projector? And also, if you don't know, and the manufacturer doesn't give it to you, there's actually a website you can go to, colorlightoutput.com. And you can spell that both ways, with a U or not. And so colorlightoutput.com, as projectors get tested, so my laboratory does testing, as well as another laboratory, Intertech, does testing, and that data gets aggregated at colorlightoutput.com. So you can look up a projector model and find out what the color light output of the projector is.
So when you ask a manufacturer, CLO information, they don't give it. What do they like to come back to you with to explain why they can't give you CLO information?
Well, I've heard everything. Sometimes it just means they've never tested it. And the most important thing to remember is that if it's a 3-chip system, the chances are it's got very good, it will. If it's a 3-chip system, it's going to have very good color light output. But if it's any other type of system, 2, 1, 4-chip, and it's using LED, for instance, because a lot of 1-chip LED systems, they don't have color wheels, but they can create color wheels on the fly because they can change their timing automatically. So all kinds of new technologies have different outputs. And so if you don't see it, look it up on the website. If you ask the manufacturer, they may say, oh yeah, it has great color light output. Okay, what is it?
So is this a form of measurement we can use across projectors and displays?
Actually, there is a display version coming. There's 2 ISO committees, one working on LCD, one working on OLEDs, and they're both bringing the color light output into those, but that's not there yet, still working on it.
Is that quite difficult to do then, I suppose?
Well, just moving things through.
The specs are changing, aren't they?
Changing specification is actually an extremely slow process. Like I said, this was an 8-year process, but we're working within multiple ISO committees, and there's an entire ISO committee that's working on bringing all specifications for display technology together. So there's a working group right now that is actually looking at saying, okay, this is how we measure contrast here, this is how we do it here, how can we make those similar across all display technologies? That's coming, but that's probably still a ways out. That's a fairly new committee, but they are working on that.
What would you say is more important, color quality or color accuracy or image quality? Are they both the same thing, Craig?
It's all.
It wraps up, aren't they?
It all overlaps. From my point of view, it's been, the practical issue is just to make sure that the projector's lined up properly and you get the maximum contrast ratio on the terminal image as you can. one thing I was going to ask you is that, the vast majority of projectors sold in this hall, they're going to go into an environment, say, somewhere between, say, 50 and 500 lux. Talk to me about the color in that kind of real world.
Sure. So I don't know if you've seen the demo that we've got set up over at the Epson stand. You'll need to come over there and check that out. We actually have a lot of fun. We've got 4 projectors set up in a shootout, and then we have massive light that we can dump on the screen. So we can actually see how a projector with low color light output is incapable of getting over the ambient light problem. So the thing you need to understand is, well, can we talk a little bit about color spaces and input spaces? Yeah. So I got these models in front of me here, but this is a model in LAB color space. So this is human perceptual color space. Most people think of RGB as a cube, right? Because the numbers go 0 to 255 linearly, right? So they think it's 255 this way, that way, and it's a perfect cube. But actually, when we look at color, that perfect cube, you'll notice this is actually 6-sided, just like a cube, but this is actually the shape of color. So this is black on the bottom, and this is white on the top, okay? Yellow over here, this is green, there's red, there's blue down here. In this light to dark, okay, this is the black again, so moving up in lightness, and as we move out from the center, that's hue is around here, and then the saturation is the distance, okay? So basically things like yellow should be almost as bright as white on a projector, because that's the way the input signal is designed. When a designer, a cinematographer, anybody who is creating content, they're working on reference monitors. These are perfectly accurate color monitors. And when they're designing that color, when the director is working with the colorist on a piece, he's actually simply looking at a reference monitor, and he sees the color exactly the way he wants and makes the adjustments. So that input signal that's coming into our projectors is perfectly calibrated, all right? And the job of a projector is simply to reproduce that information, because that information is accurate, okay? So that's what a projector is supposed to do. And if it was doing that, then this model would look exactly the same. If I was to measure the projector, I would get this same shape back out of the projector if it was doing its job. But what we find is we get a lot of different things. Okay, so if I take these same, you notice on here I have all these little points on the surface. Each one of those is an RGB value. You went into Photoshop and typed in a number, right, for red, green, and blue, you get each of these points. So these are actual measurement points. If we take those same points and feed them to a projector, we might get something like this. Okay, so this projector is a 3-chip projector. It's a 3 LCD projector. And what you're getting on this projector is those same points, but you notice it's a different shape. This in sRGB, we can actually measure the volume of this. So we talk about color volume in color science. And color volume, this is about, one of the fun things is I make these models so they're 10 centimeters from light to dark. So you can actually use milliliters to measure this. If I were to fill this up with water and pour it out, I could tell you how much color is here, right? And so this is 830 milliliters. In color science terms, 830,000 units, okay? But about 830 milliliters, okay, to make it simple. This one is actually a little smaller. This projector is in its bright mode, okay? So after we take account for its white point, you'll notice it has slightly less range here, has about the same range here. It's just a little bit different. This projector is producing about 650,000. So 650 milliliters compared to the 830, okay? And then this projector here, which is in the exact same price range, okay? Same lumens category. So they're both claimed, in fact, this claims to be a 7,500 lumen projector. This claims to be a 7,000 lumen projector, okay? So we go into the same, and yet this one, you can see, has much smaller gamut. In fact, the gamut here is about 230,000 or 230 milliliters. So this is a much smaller range of color. And what you also notice is that the colors are dark. You can actually find this dark red on the sRGB model simply by walking down in brightness, and there it is, right? So this whole range of color, that whole slice of color, it's not capable to reproduce the input signal that's being sent to the projector because the projector's red isn't bright enough. People think of the color gamut of a projector as being that CIE chart, right? I actually have a chart for you which you can look at here. And if you look at a projector, right, normally you look at the lumens number and then you look at that CIE chart. And here we have 3 projectors and you have 3 CIE charts, and the CIE charts look pretty much the same, okay? Because the XY chart only tells you about chromaticity. It only tells you about that hue and saturation component. It doesn't tell you how bright it is. So if you take the same chromaticity and you walk down brightness, Okay, that's moving along this line here. So all of these are on that same point on the chromaticity chart. All of these are on the same point on the chromaticity chart in blue, and all of these are on the same point. So you're not getting the brightness information. With the standard 3-chip projector and the old standard, you didn't need that information because that's what lumens provided. But when we started to get projectors that actually didn't produce red plus green plus blue equals white, okay, they actually had color brightness lower than it was supposed to be, then we started getting distorted color gamuts. But it doesn't show up in the CIE chart. These 3 projectors here, the CIE charts, they look roughly the same. There's a tiny bit difference, but anybody who looked at those charts, yeah, it's very similar. You would say this projector over here, 3,000 lumens, it's the brightest, this is the darkest, and that's sort of in between. And that was the only information you had. But when we go to the new metric, you see a vastly different result.
Dramatic.
Okay, now if we look, this one still has 2,200 lumens of light, like we said, but its color lumens is also 2,200 lumens. So the color light output of that projector is equal to its white light output. However, the one that was brightest, 33,000 lumens, has only 900 lumens of color. With only 900 lumens of color, you're never going to be able to reproduce what the designer intended. And that's completely hidden from the buyer, unless the buyer takes a sophisticated measurement device and shoots out the projector extremely carefully and is very sophisticated in their buying, which, as we know, most people look at a spec sheet, right? Or you're looking to fill, one of the biggest problems is we have like universities and different people like that. They have a set of specifications and they're based on the old light output spec. So they go through and they look at the prices based on the spec. So color doesn't even show up.
Karl, I've got a question. So if you track the difference between, the delta between, true color and and then mapping out what the projector kicks out, how does that track against the human visual perception?
Right. So one thing to understand is that these models, this is perception,
yeah,
right, as opposed to colorimetry, which is just measuring the color. And so if we look here, I can show you a great example. So any business, they define specific colors, like the color of their logo, right? AV Magazine has a red, and I bet there's a Pantone color associated with that, right? And so that Pantone color, the Pantone Corporation defines that particular Pantone color in LAB space, okay? They actually have a specific value in LAB, and that's human perception. So here I have another company that I've worked with in the past, Jelly Belly, and they make all of these jelly beans, right? And they actually have a specific LAB value for every one of their jelly beans, because you have to know what flavor it is, right? They print out something on the chart and they say, the lemon yellow jelly bean is supposed to be this color, okay? And they actually know what that color is in RGB, so in sRGB space, they know exactly what color that is. It's 255 red, 255 green, 25 blue. And here it is in LAB. First thing you notice here is that L, that lightness amount, right, is 97.6, while white's 100. That yellow is very bright. It's almost as bright as white. So that's the color of that jelly bean. So if they wanted to project on a projector in their trade show booth that jelly bean, right, that's what they'd want that projector to do. Well, here's what an example of a bunch of projectors actually do.
Can you just very briefly explain what LAB is and its relevance to this?
Yeah, so in fact, on this slide here, you can actually see how we get to LAB. So we measure the black and white of the projector, and then we measure the actual color. And we do that in XYZ space, which is the space of the cones of the eye, okay, what we call the color matching functions. And then there's mathematical transform that takes it into the way the brain sees it, because the brain sees all color relative to white. So the luminances of all colors have to be relative to each other. So the projector, right, the projector has to have all of the relative luminances correctly, otherwise we won't perceive color correctly. So here you can actually see a projector trying to reproduce that lemon yellow, and it gets this sort of lovely olive green color, which is actually the right hue and saturation. The only thing incorrect in that is its chromaticity. And then we, in color science, we actually use something called delta E. Now delta E is a measurement of color error, which was the question you asked me, is what is the error? Can we measure that? And absolutely, we have that. The international standard, CIE delta E 2000, was created by the CIE. They're the color experts of the world. And for instance, in the printing industry, it's a great example. You could take a logo and you put it on your business card and you give it to the printer, and the printer has a responsibility to reproduce your Pantone color, okay, within 3 delta E. That's the job of a printer. And if they don't produce it within 3 delta E, they're not doing their job. And we can measure that, okay? That happens every day in the print industry. here's a projector which is reproducing that lemon yellow, 19.9 delta E of error. Okay, so that's almost right 7 times what the error would be allowed on a print job. Here's another projector that's doing it at 33.8. Okay, so if your printer did that to your logo, you would switch printers right away and throw the job back at them.
What happens when you get a specification like this and you're looking at this much detail into it? Can you change the way the projector behaves with the manufacturer?
Absolutely not, and that's why we have color light output.
Okay, right.
Because if the projector can't produce the brightness of color, no other spec or adjustment or calibration makes any difference.
It's
sort of at the end here.
Capability of the projector.
Yeah. When we get to the end of this, we'll talk about modes. I want to talk about modes, but I want to keep that to the end because everybody asks me, "Well, I can go in and calibrate the projector," but the key is you can't actually calibrate a projector brighter than your color light output. So if a projector has 7,000 lumens of white light output and it only has 2,000 lumens of color light output, when you perfectly calibrate that projector, it's going to be a 2,000 lumen projector. So that's why that's the number. It's the only number you need to care about, because when you calibrate the projector or you put it in its best color mode, you're only going to get the color light output. You're never going to get that old number. And that's why we changed the number, because, hey, you want to know whether you can reproduce the input signal, right? So basically here you see that some projectors can do it, some projectors can't. This little movie right here, all of those, that's 600 different colors from a projector, and those lines represent that error. So in the original here, going to this one, every one of the points on here has a corresponding point on here. And so the distance between those points, that's that color error that we were talking about. So every one of those lines is an error for an individual color.
How much does the difference change over the lifetime of a lamp, over the lamp maintenance factor?
So lamp doesn't actually change. Light output will go down, but it goes down universally.
Okay.
So the ratio will stay the same. If you have a 7,000 lumen projector with 2,000 lumens of light output, or let's make it easier, say 10,000 and 2,500, okay? So it's 4 to 1, all right? Now, they'll just move down like this. So it'll always be 4 to 1, and everything will stay there, because the lamp is just getting darker, and so all of the optics and everything in the projector just works in the same way. Right, so it's proportional as the lamp goes down. And it doesn't matter if it's a laser light source or anything else, when we measure that color light output, it's always going to stay fixed as a ratio to white. And what you want, remember, the correct light output, because that's what the input signal in, is exactly the same as white. White and color light output should be equal.
I think from a practical perspective, it would be very useful for us to talk about modes, because that's kind of one of those common things that comes up.
So here's a great example. Here's a projector that is 2,200 lumens, and its color light output is 750. Okay, so it has that ratio of 2,200 to 750. And we can see a wireframe, and that wireframe is the sRGB color space that's being sent to the projector. And then the solid that you see there is the actual result of the projector, like this. And this projector is in bright mode. Now we always measure it in bright mode because that's what they're selling you. They're selling you the brightest mode of the projector, and if you want 7,000 lumens, then you need to try and get 7,000 lumens because that's what you need, right? So the bright mode of the projector is what we do the specification in. However, if you take that same projector and now you put it in its best color mode, so this particular projector has a mode they call sRGB, okay? So we're going to put it in sRGB, and you see the gamut got bigger. Okay, boom, the gamut. Why did the gamut get bigger? Because white dropped down to 850. You'll notice color, we lost a teeny bit of color. It went down to 700, okay? So now they're very close together, like they're supposed to be, okay? Because in order to make good color, white and color light output need to be the same. So the great thing about the color light output number, all right, what it gives you is it tells you what best color mode is going to be, right? You're never going to be able to get more color than whatever your color light output is. So it's actually telling you the truth about the projector. Whatever the projector is going to be able to, can't be more than the color light output.
Yeah,
so the color light output number is all you need.
Well, how have the manufacturers reacted? They may have been involved with all this stuff.
Well, there's a bunch of manufacturers that love it, and there's a bunch of manufacturers that are not too keen on it. And then you have this wonderful mixed line, because you have a lot of manufacturers that produce products that are really great, as well as ones that are not so great under the color light output metric. And they're very conflicted, because they want to talk about their ones that are really good, and so they want to put the metric there, but they don't want to mention it about some of their other products. And so you see a mix within a lot of projector manufacturers. So when you talk to them about color light output, if they're being honest to you, they'll say, well, it's a very good metric, and it's good. But on the other hand, if they have products that don't look so good based on the metric, they may not want it. And that's why we've sort of forced the thing with this colorlightoutput.com website, because we wanted to just get numbers out there. A bunch of manufacturers are putting the numbers on the box, and we just want everybody to switch to it. The best thing is you'd put both on the box. That's what, for instance, Epson and Sony do. They put both numbers, or at least just put color light output, because that's really all you need. And the great thing about the number is, from the installer's point of view or the specification point of view, it's just like the old number. If you need 7,000 lumens based on your spreadsheet that you have that calculates these things and your experience and things like that, then the new number is exactly the same for you. It means exactly the same thing. It just means you're going to get good color at that brightness. So the new number is no different for the consumer. They just need to make sure they're using it instead of the old one.
Does it, in the applications you choose, does the variation of color, is there a variation of color according to the application's requirements? Or are we dealing with a uniform value of output here?
No, I think the most demanding specs that I work with are in with simulators, and because it's all based on CRT, they're kind of lost. They've accepted a trade-off. And this is fascinating, because how much traction has this got in the States?
Well, we've been working on it a little longer there. So this is our second year in Europe trying to move the color light output metric out to the end users, right? So we've got a lot more. We've got some significant traction in the States. Now, the important thing to remember is, for the people in the high end, so the people I work with in the States, and you mentioned simulators and stuff like that, they absolutely require color light output to be exactly the same, because they can't reproduce the accurate results otherwise. There's actually a company that I've talked to, they're working on simulators for some of the latest fighter jets, right? And they've got 20, 30 projectors in there. Those projectors absolutely have to reproduce color and in light and dark is absolutely exactly correctly. So color light output has to be exactly the same as white light output, no doubt about it. That's an absolute for them. Anybody who has strict standards, color light output is the only thing they care about.
But you say that. I'm thinking about some of the larger simulator companies, and they've got some really quite expensive domes with single chip projectors, and they have to be very careful themselves, how they specify color, because again they're going to draw attention to the delta between the machines that they've got there. So that's
right. Well, and it depends on what the simulation is being used for. But if it's if it's a serious simulation where you're trying to reproduce the world outside, you can't not have equal color light output. And so what they're probably doing is not using the white segments in those projectors if they're one chip, or they're just red, green, blue color wheels. Yeah. Remember that if you have a one chip projector and the only thing in there is a red, green, blue color wheel with no white segment, no cyan, no yellow, your color light output is still going to be pretty high compared to your white, probably close to 80 or 90%. It's very important to understand that color light output at 3-to-1 and 4-to-1, while it exists in some projectors, okay, doesn't necessarily always be that big. It can only be a small amount. And then when you calibrate those projectors, it's not as bad a hit, okay? And if it's an RGB only color wheel, which we see a lot, for instance, in home cinema, all right? They only have red, green, and blue. That's how they make white. Now, they actually do get a little bit of cyan, magenta, and yellow by the spokes. So when the red and the green come by in the color wheel and both are in front of the integrator, okay, they're mixing red and green together, so you get a little bit of a secondary color. And they actually use that, and they add that to the white part of the screen. That's why you do see a small difference in a red, green, blue only wheel. We're not saying that in a one-chip system you can't do this. You can. Okay, and it's much more inefficient for the lamps to do so. And we're actually starting to see two-chip systems, right? From some of the laser phosphor things where we've got one chip doing a red laser and one chip doing, yellow phosphor and being split to green to blue, and all kinds of sophisticated stuff is starting to happen in the light engines. The great thing about color light output is it works with all of those new systems, and it gives you a realistic understanding of what it's going to be able to do. One number answers it for you.
That's fantastic, Karl. Thank you so much.
Certainly.
Greg, thanks.
Thank you.